Welcome back. So let's talk about k-means clustering. K-means clustering is one of the algorithms to find clusters in the data. And remember, we are talking about an unsupervised context. We do not know what clusters there are. We do not know how many clusters there are. We are using an algorithm to detect potential clusters. In the example, I'm going to show some clusters, but that is only to demonstrate how it would work. In real data, we don't have this. K-means clustering, you might be a little bit of a thought experiment to try to figure out how it works, but in some ways it is one of the most straightforward, perhaps, algorithms that we get in this course. I think K-means clustering is probably one of the easiest to understand, especially visually. Here's a little bit longer description of it, which will be a bit abstract, but the next few slides will show visually how this works, and I think that makes it easy. So K-means clustering is a clustering algorithm to search for the optimal clustering in K groups. So note that we have to say how many groups there are. The computer will not detect how many groups there are. We will say, here's the data set, please find the 3 main clusters, or the 5 main clusters, or the 20 main clusters. So the input for the command to find the clustering includes all the X variables, all the variables on which we think the observations cluster, and the number of groups we wish to detect. And the clustering basically follows a number of steps that it repeats. First, it will have K random starting points. It will, at completely random locations in this data, say this is the center of cluster 1, this is the center of cluster 2, this is the center of cluster 3. This is random, so that does not tell us much about the data. In the second step, it will take each observation, look which randomly allocated point is nearest, and assign that observation to that group. So if one observation is close to the center of the cluster 1, we will say that observation belongs to cluster 1. If another observation is near cluster 3, we will say that observation belongs to cluster 3. Now, this is still based on this random assignment, so this is not very informative, but then the third step is the key. We will take all these K center points, we will look at all the observations that belong to this cluster because they were nearest, and then we take the mean of all those observations. We take the center point of all these observations, and we move the point to that center. And then we repeat these last 2 steps. So we go back to step 2, and because all these K center points have moved, they're in a new position, we will reallocate every observation to whatever is now the nearest point. And then they have been reallocated so the K points can move to their new mean average for all those observations. Now, this is really hard to follow in an abstract sense. I will maybe show you the slide again at the end, but let me first try to do this visually. So here is some fake data. We're going to find 3 groups. This data has actually been generated with 3 groups present. It's a little bit cheating, but that's just to demonstrate. So imagine we have 2 variables, x1 and x2. x1 is here on the horizontal axis, x2 is on the vertical axis. These are the 2 variables that we're interested in, and we want to know whether observations cluster. Let me use the pointer here, that will probably help a little bit. Spotlight. Yeah, so we have here the x-axis, we have here the y-axis. So this observation, for example, scores high in x1 and also reasonably high in x2. This observation scores high in x1 but very low on x2, etc. It's just a scalar plot. And the data has been generated so that there are 3 clusters. There's the red cluster, the green cluster, the black cluster. But that is only for demonstration purposes. That is not normally the case. So what normally the data looks like is more something like this. Same data, but we do not know how many groups there are. We do not know what those clusters might be. So the input data that goes into the K-means clustering data is this. We have the coordinates on x1 and x2. So for those 2 variables, we know where each observation is located. And we are asking the algorithm, do you see clusters or groups in this data? And so the first step it will take is just random locations for the centers. So here we have a green, a blue, and a red dot, and they are randomly assigned. So they have no substantive meaning. It is saying this is the center of the blue group. This is the center of the red group. This is the center of the green group. And then we can assign each observation, we can color them based on those locations. So the locations have not changed between those two slides, right? The locations are the random locations, but all of the ones that are above these two lines, all these observations, the nearest center point is this red point. And all of these observations, the nearest center point is this blue point. And for all of these observations, the nearest center point is the green point. So we have random starting points. And for each of the observations, where we know the x1 and the x2 coordinates, we look at which of the center points is the nearest and we assign them to that group. So we say these are all part of the red group, these are all part of the blue group, these are all part of the green group. But this is an iterative algorithm. Iterative means that it takes several steps in a row to get a better solution in each step. And it keeps doing so until it is satisfied. So in the next step, it moves all these center points. The point that was here, that is now the center point for all these red points, goes to what is actually the center of those red points. Yeah? So of course this was a bit on the edge. These points are far out here. So it moves to be more in the center. It takes the mean on x1 and the mean on x2 for all of these observations. The center for the blue group was already fairly close to the center of those points and moves a little bit here. And the green point takes the mean. You can see there's a lot of points here, there's some points here, so it gets dragged in that direction. There's only a few points here. So it gets dragged by this. So that is the mean point, the mean on x for all the green points and the mean on y, or x2 for all the green points. So we have moved the points. Now we can reallocate each of the groups, right? So for example, the observations here that were closest to where the closest center was red, with red moving all the way here, suddenly they are closer to blue. Yeah? And we see that those observations have indeed now turned into the blue group. So for these new centers, we have a center here, and we have colored all of these green because the nearest point is this. And we've colored all of these red because the nearest point is this. And we've colored all of these blue because the nearest point is this. But now, of course, the group assignments have changed, so these are not really the center points anymore for those groups. So in step 2, we move them again. We lost these observations here, so that drag for red, so that drags the center in this direction. We gain some observations here, that drags the green in that direction. And the blue is attracted a little bit by these points. So the mean center points change. The steps become smaller, of course. Every iteration, the steps become smaller. And we can reassign them. So now, these are all closer to blue, these are all closer to green, these are all closer to red. In iteration 3, they all move a little bit again, in the same direction, more or less. That can change a bit, or more or less, that depends. We reassign, we move them a little bit again. Now, in this iteration, you see that the red has hardly moved at all, right? So it was pretty much at the center of the group. The green moves a tiny bit, the blue moves a tiny bit. So we can basically stop the algorithm. It is not really going to change anymore which group any observation belongs to. So after a few iterations, in this case very fast, only 4 steps, after a few iterations, we get in a fixed position where we have all the groups assigned and there is no point in searching anymore. Yeah? So here we have asked the system, we have entered all these black dots where we do not know the group. And we have said, find 3 clusters. And it did so by first taking 3 random points, then assigning each observation to the nearest cluster, then find the center of all those observations that belong to each cluster, and then repeat this over and over again. And you will see that it finds this space. It finds this cluster here, a cluster here, a cluster here. And we can see where the center is of each, and we can see to which cluster each observation belongs. And that last part, we are now going to look at in a table. So in a way, this is unusual data. It is unusual data because we knew that there were 3 groups. we had generated the data with 3 groups in mind, and we had already assigned, looked at those 3 groups. That is not normally the case. So where in a logistic regression or a discriminant analysis, we can often create a confusion matrix between the real labels and the predicted labels. But in cluster analysis, you can normally not do this because you do not know the real clusters. So you can't make a table between real clusters and the found clusters. But in this demonstration data, that is just for the lecture, we did know the real clustering. And we can see that there is a really strong pattern. So we have 3 groups, we found 3 groups, and most observations fall within those. Now, we didn't have labels or numbers, so what we called the red group is now maybe the blue group, what we called the green group is, right? The system did not know which colors we started, and it started with random ordering. But we can see that what was 3 distinct groups also remained more or less 3 distinct groups. There are only 2 observations here, and another, what is this? So there's about 16 observations that are not exactly classified in the same cluster, but most observations are. Yeah. So the numbers are irrelevant. So this shows that the algorithm does very well in identifying these clusters that were in the data. But normally we just have to trust the algorithm. We will find us clustering, and that is what we can work with. So we can also do the same. This is the same data, right? And now we start with 5 clusters. So as I said, you have to give as the input how many clusters there are. In the data generation process, there were 3. But we didn't know there were 3. If it was real data, we wouldn't know there's 3, so you just try different things. Here we try with 5 clusters. I'm starting to worry that one of them might have been colored in white. But in any case, oh, there's one in purple below that fell just off the screen here. Yeah, there's a purple one here that we can't see. So the bottom line is we have these 5 points, purple out of sight, and we can allocate each point to the nearest cluster, and then we can repeat this. Every point now moves to the center of their group, and then we can reallocate. Yeah, and we can do this a few iterations. So here we can move them again and reassign, move them again, reassign. So these clusters keep refining, and it keeps detecting better where the real clusters are based on this algorithm. Yeah? And these steps become smaller and smaller because each time the changes are less, because it has already found, it approaches the center of a real cluster. Yeah? So I will stop there. But the key things to remember here are, there's a relatively straightforward algorithm, but the key is that you have a number of X variables, and this can be many variables. In the labs, we will use an example where there's actually hundreds of X variables. But to visualize, I show it with X1 and X2, but there's many. And all the observations are somewhere in this space, defined by X1, X2, X3, X4, X5, etc. And then we try to find these clusters. We have to say in advance how many clusters we wish to find. And it will tell us then a result with exactly that number of clusters. And it will tell us where the center is and to which cluster each observation belongs. So I will stop there, and we will continue with hierarchical clustering in the next video.